Okay, I'm Jackson Irving, and I'm going to be presenting topic 4, which is quadratic applications. So, quadratic applications is a process that is 4 steps. So, to graph a quadratic. So, step 1 is the equation that we'll be using, which is ax squared plus bx plus c. To determine the concavity of the function, you look at the a variable. So if a is greater than 0, then the function opens up. Like so. If a is less than 0, function opens down. Like so. So if you have a negative for the a variable, it opens down. If you have a positive, it opens up. Step 2 is finding your vertex. To do this, you use the negative b over 2a formula. And then step 3 is finding your y-intercepts. To find your y-intercept, you take the c variable of the function. And then step 4 is finding your x variables. To do that, you either use factoring, or we write down the quadratic equation, which can also be used. All over 2a. Okay, now we're going to start the first example problem, which reads as: determine the equation of the quadratic function which passes through the points 0, 12, 120, and 342. So step 1, we want to start by plugging into our equation for the first coordinate, which is 0, 12. So we want to write it out as a0 squared plus b0 plus c equals 12. This is because the x for this coordinate is 0 and the y is 12. And ax squared plus bx plus c equals y. Okay, so since our x is 0, it makes this a lot easier because the a and the b are both 0, so c equals 12. So then moving on to our next coordinate, which is 1, 20, we have a1 squared plus b1 plus 12, which is our C, equals 20. So now we want to simplify the equation. So we'll move 12 to the side, and we'll have A plus B equals 20 minus 12, 8. Now we'll do our last coordinate, which is 3, 42. So A3 squared plus B3 plus 12 equals 42. So for this one, we do our 3 squared, 9A plus 3B, 42 minus 12 is 30, equals 30. Okay, so we already have our C. Now we need to find our B and our A. So we're going to stack the equations on top of each other. So A plus B equals 8 over 9A plus 3B equals 30. So now to cancel out, B looks to be the easiest. So we're going to multiply the top equation by -3. We're going to get -3A minus 3B equals -24. Now you're going to stack those and solve them. So it's going to come out to the B cancels out, and then you're left with 6A equals 6. Solve that, A equals 1. So now we have our A, and we can plug back into any of the equations. So we can just use A plus B equals 8. Plug in our A, which is 1, plus B equals 8. Subtract the 1, B equals 7. Perfect. Now we write out our final equation in our ax squared plus bx plus c form. So f of x or y equals x squared plus 7b plus 12. And that is your final answer. The concavity is up because the A is positive. Okay, now we're going to do example 2. And also note for the last one, I had x squared plus 7b plus 12 as the answer. It's not 7b, it's 7x. Okay, now on to example 2. It reads as determine the equation of the quadratic function that passes through the points -2, 18, 1, 12, and 3, 20. So this one's going to be a little harder because we're not given a 0 as an x value in any of the coordinates. We're going to still go through the same way. Start with -2, 18. Plug it into our equation. Now simplify it. -2 times -2 is 4. So we have 4a minus 2b plus c equals 18. Now to the second one, 1, 12. So we have a1 squared plus b1 plus c equals 12. Now solve that. 1 times 1 is 1. So you have a plus b plus c equals 12. Now do your 3, 20. You have a3 squared plus b3 plus c equals 20. So 3 times 3 is 9, so it's going to be 9a plus 3b plus c equals 20. Now, we're going to have to stack these equations again to try and get first our c variable. So let's start with a plus b plus c equals 12. Underneath that, we're going to put 4a minus 2b plus c equals 12. All we're going to do here is multiply the first one by -1 to eliminate the c. So it's going to be -a minus b minus c equals -12. Cancel it out. It's going to come out to 3a -2 minus 1 is -3, so minus 3b. There's no more c equals 0. Okay, now we're going to do the same thing with the bottom equation. We're going to go a plus b plus c equals 12. Under that, we're going to go 9a plus 3b plus c equals 20. We're going to do the same thing, multiply by -1. It's going to come out to -a minus b minus c equals -12. Cancel those out. Get 8a plus 2b equals 8. Now we're going to go ahead and stack those two equations which we just made. You go 3a minus 3b equals 0. And we're going to go 8a plus 2b equals 8. Okay, now here there's no perfect cancellation, so we're going to have to multiply both of them. We're going to multiply the top by 2. We're going to multiply the bottom by 3 to eliminate the b. So it's going to look like 6a minus 6b equals 0. Underneath that, it's going to be 24a plus 6b equals 24. And you cancel those, and we're left with a. So the b's cancel out, and we get 30a equals 24. Divide by 30, and then simplify. It gives us 4/5. So a is equal to 4/5. Okay. So now we're just going to plug back into the equation we just created. So I'll choose to do 8a plus 2b equals 8. But now we're going to plug in the 4/5. Okay. Get 6.4 plus 2b equals 8. Now we're going to divide the 6.4. Subtract the 6.4. Get 1.6. We get 2b equals 1.6. Divide by 2. It comes out to it also comes out to 4/5. Okay, now for the final step, plug in the ones you've just made into one of the original equations. We'll go with a plus b plus c equals 12, which because it's the easiest. So now we would have 4/5 plus 4/5 plus c equals 12. So that's So that's 8/5 plus c equals 12. Subtract 8/5 from 12. And it gives us 52/5. C is equal to 52 divided by 5. So now we just plug in all our answers back into the original equation. So we can do f of x equals equals 4/5 x squared plus 4/5 b plus 52/5. And that is our final answer.